In this video, we're going to use our graphing calculator to help us create a table of values and also solve. So when we're creating a table of values, this is the same thing as evaluating. And so, for instance, if I want to find P of 48, that means that I want P of 48 because I want to enter 48 into all these Y values to come up with the percent. And so just real quickly, we can look at Y is our input variable, and the Y represents the years since 1930, and our output is the variable P, and P represents the percent of ages of women aged 65 and over living alone. One thing to keep in mind, so we have the ordered pair Y comma P of Y, or just Y of P, Y comma P in terms of our variable declarations. Know that in our graphing calculators only understand X and Y. So the first thing we want to do is use the table feature, and so we want to put this information into our calculator and make sure that you have your notes, your calculator notes that are in the student packet available and handy, so you can follow along that way as well. And so I'm going to go to my graphing calculator, and I need to enter this function into the Y equals. So the Y equals is right here, and I'm going to type this in, making sure that this is a negative sign. So we're going to start with a negative sign, and then 0.00017. Now again, we're not using the variable Y, that's the input variable for this function. We need to use the X key, and our X key sits right here kind of in the upper middle. And then it's raised, so caret symbol, and to the third power. If you have a calculator that's putting the exponent up to the top right automatically, and then you need to use the arrow so that it comes back in line. If your calculator displayed the caret symbol, then you're going to be all in line and you don't have to worry about that arrow key. So go ahead and finish typing in the rest of the function there into your Y equals. Okay, now that we have our equation, our function typed into our Y equals, we're going to use the table feature. But before we use the table feature, we need to set up our table correctly. And once you do this once, you don't have to change it again. We're going to go to Second, Window, and notice right here that the independent or the input variable is on ask, and we want it to automatically generate the output variable, the output values of this variable. And so we're going to change the auto to ask, and so I'm going to just arrow down to that portion, and notice it's blinking on the ask. Hit the enter key to select it. If I arrow down one more time, you can see that it's bolded now. Now I'm going to go to my table, and second graph is my table. And if you have a list of values right here, just hit the delete key if it's blank, and then you're ready to go. And so you're just going to type in the input values, the Y values, which in this case is considered the X values, the input values, and it's going to automatically generate these output values. So go ahead and type those in to create your table, and then write them in the table area. Okay, as you can see, when you enter all those values, you end up with these, and I wrote them right here as well. And before we graph this, I just want to quickly go over, is this graph discrete or continuous? Well, again, we're asking ourselves, can we break up years into partial fractional pieces that make sense? And the answer is yes. And can we break up the percent of women? And that answer is also yes. And so the graph is continuous, which means we're going to connect the points when you graph your function. So go ahead and spend just a minute to graph that. Okay, you have probably a graph, something similar to what I have here. And now we want to actually graph this using our graphing calculator. But in terms of using a graphing calculator, we first have to tell our graphing calculator what the window is. And the window is the graph paper for the calculator. And so our calculator needs to know where it wants us to graph, just like we give, an axis over here. So we're going to examine So our x's, just as we pointed out up here, that the x is our input and y is our output. So our x again here is our input, and our output is the y. And so these are our input axes and our output axis, and this is what we're going to count by or scale by. And so we're going to go from -10 to 110, and it looks like we're counting by 10. We're going to go from 0 up to 40 and count by 5s. And so now in our graphing calculator we're going to do the same thing, and so we're going to hit the window key and we're going to type in -10. It's already there, and again remember, if it's not a -10, make sure you hit the negative sign, and then 110. We're going to count by 10s, and then we're going to go from 0 to 40 and count by 5. And again, depending on which calculator you have, you may or may not see any of this. It doesn't make a difference what these things are down here. And now we're going to hit the graph key, and you should see a picture very similar to what you were drawing here. But notice in my graph, my ending part of my hand graph, I go beyond the graph existing axes, where it seems to actually touch the horizontal axes somewhere between 100 and 110, and we're going to find out what that value is specifically in a couple of minutes. But now we have a sketch, an accurate sketch of what that function looks like. So next we want to solve, and we want to solve the equation by using the graph when the percent is 6. So we're going to go to the graph and look for the percent of 6, and I'm just going to kind of draw a line through it and see. So it looks like, based on my graph, and yours will be a little bit different depending on how yours is, it looks like my answer might be about 108 years. And so I know that 6 equals P of 108, and it's asking us to write as an ordered pair. So again, this is our input value, this is our output value. So we're going to say 108, 6, because we're looking for that intersection point. And so now we're going to use our graphing calculator to solve using a more accurate method. And so in y1 is already our equation, and that's what we want to leave it as. But in y2, remember that this 6 is a percent, which means this is an output. And so, and the y is an output, so we're going to put in the number 6. So we're going to go to our graphing calculator, go to y equals, and in y2, and notice it's telling you y2, we're going to type in the number 6 and hit enter. And at this point, we are ready to find the point of intersection, provided we can see it on the graph. And so we're going to hit graph, and sure enough, we can see that intersection is somewhere, looks like it's a little bit, it looks like it's between 100 and 110, and we're going to have the calculator find out exactly what it is. And so as you're looking on your sheet, you know that the steps are second, trace, the number 5, and then the enter key 3 times. And so second, trace, and you'll notice intersect is number 5, and that's what we want. We want to know the point of intersection, so I just hit number 5, and then I'm going to hit the enter key 3 times. And I find out that the answer is 103.15. And so I am going to, so it's asking us to solve, so we know it's y equals 103.15 years, or the other way we can write this is 6 equals P of 103.15. So the other thing we want to find out is the horizontal intercept. And if you recall, the horizontal intercept is something, some input value, comma 0. So again, that means that we know the output, and the output value is 0. So that's going to go in our y2, and our equation is going to go into y1. It's still sitting there, and you're going to do second trace 5, enter 3 times to do this again. And so go ahead, and so we're going to go to y equals. We're going to change our 6 to a 0, hit enter, graph, double check to see we can see the point of intersection, and the color calculator shows that you can see it faintly there. So second trace 5, enter 3 times, and you end up with 106. And so we know that the something, the y value, is equal to 106 years. So that must mean the horizontal intercept is 106, comma 0, which would mean that there would be, after 106 years, 0% of women age 65 or older living alone. So the practical domain is going to be the years again. So from 0 less than or equal to y less than or equal to, we ended up with 106. Although we know that's probably not true because we'll always have people living alone, but that's where our model ends. And then our output values are going to be 0. This is saying that somebody will, or at some point the percent will be 0. If p is greater than or is less than or equal to, and then if we look back up to our graph, it looks like the highest point is probably about 38.33. It might go a little bit higher than that. We're just going to use that as a point of reference to 38.33. For this problem, so the second one, to solve algebraically, so we would do -2 equals 5 times the quantity p minus 11. And so we would divide by 5, so -2 fifths equals p minus 11, and then just add 11 to the -2 fifths, and your calculator can do that quickly for you. So we get 10.6. And then we want to use the intersect method again. And so the equation is 5 quantity x minus 11, which is what you put in your calculator here. Your y1 was 5 times the quantity x minus 11, so you could generate the table. And then our output value is -2, since that's what we are trying to find. And now here we want to look at what our window should be. So if we want values from -4.6 to 20, I want to go from -5 to 25, count by 5s, and our input values are going to go from, so those output values are going from -78 to 45, so maybe we want to go from -100 because we want to capture the -78 to say 50, and we can count by 10s or 20, somewhere maybe even 25. And then this part for the justification is just telling us, why are you picking -5? Why are you picking 25? Why is the count by 5? And so on and so forth. Just a short, quick justification about why those values were picked.